In the previous video, we set up DHCP services in combination with our edge nodes and our single tier 1 router to provide DHCP services to our network segments. In this video, I'd like to kick it up a notch and have not just one gateway, but actually set up 3. And that'll give us a good example of setting up a tier 0 at the top and then connected to it below that 2 tier 1 gateways. And then those tier 1 gateways can then furthermore be connected to network segments, and then we can have routing inside of our infrastructure using those 3 routers. So here is our current configuration right here, and here's what I propose you do. We'll simply modify this topology, and we'll put an additional router here, an additional router here, and we'll make this a tier 0 gateway at the very top of the heap, and then at this level, we'll make these 2 tier 1 gateways. And that would be this. We'll create a new tier 0 gateway. We'll link that up with a couple of tier 1 gateways, and then over here on the left off of tier 1 gateway A, we'll attach segment 10, and over here on tier 1 gateway B, we'll attach segment 20. And then we'll use .1 for the segment 10 over here and .1, and again the address space here will be 10.10.0, and over here on segment 20 it'll be 10.20.0. And one of the other cool things is when we start linking tier 0s to tier 1s, it'll automatically set up IP addressing for the communications between the tier 0 and the tier 1. So we don't have to manually assign IP addressing space here at point A or here at point B. It'll do that part for us. And so you can see the entire process from soup to dessert. We can also verify all of that here in our nested environment. I'm going to go ahead and update or modify our existing topology, and then we'll put in this one as shown. So back here at the NSX Manager, if we go to the Networking tab, and let's go ahead and peek at our network topology by clicking right here on Network Topology. So we have segment 10, segment 20, we have some VMs connected there. And what I want to do is I want to remove this tier 1 router from being directly connected to these 2 network segments. Now, because we currently have DHCP services on those segments that are being provided by that gateway, I'll first need to go ahead and remove the DHCP services before it'll let me remove the gateway from those segments. So let me do all that right now. So let's start with these segments. We'll go to the segment section here under connectivity. We'll edit segment 10 by clicking on the 3 dots and clicking on edit. And then we'll go ahead and delete the DHCP config, click on delete, then we'll scroll down, click on save, and click on close editing, and repeat that process for segment 20. 3 dots, edit, select delete DHCP config right there, click on delete, scroll down, click on save, click on close editing, and that looks good to go. And then we'll go to our tier 1 gateways, and I'm simply going to click on the 3 dots there and delete it, and click on delete. And it says, oops, can't delete it as it either has children or is being referenced by other objects. So I'm going to click right here on linked segments. And because it's still connected to those 2 segments, that's why it won't let us delete it. So we'll fix that by going back to our segments. I should have done that earlier. We'll edit segment 10, and we'll simply say, you know what, you're not going to be connected to that gateway. And we'll click on save, and then close editing, and then we'll edit segment 20 and edit, and we'll also say it is not connected to that gateway. Click on save, and click on close editing. And now if we go back to our tier 1 gateway, in fact, if we look at network topology just to confirm, and then we have this tier 1 gateway which is not connected to those segments. So now we can just go ahead and delete that tier 1 gateway. So we'll go back to tier 1 gateways, click on the 3 dots, click on delete, and it is gone. And so we can click on refresh here just to confirm it is no more. All right, fantastic. So we have our segment 10, segment 20, those are both in place. Let's first of all create our tier 0 gateway up here at the top, and then we'll create our tier 1 gateway A and tier 1 gateway B. And when we create those, we'll associate those with this tier 0, and that'll cause the automatic connectivity there. And then also during the creation of these gateways, we'll also associate them with these segments. Segment 10 over here for gateway A and segment 20 over here for gateway B. So with the networking tab selected, under connectivity, let's start off with our tier 0 gateway and click on add gateway. And from the dropdown, we'll click on tier 0, and based on our game plan, we'll name this tier 0 gateway 0. Just like that. And as far as the HA mode, we have 2 choices, active, active, or active standby. And to implement this high availability, it's going to be leveraging the edge nodes, those VMs that we deployed as edge transport nodes. So I'm going to go ahead and use active standby as the HA mode, and then it's required here to go ahead and specify our cluster to support that function here on our tier 0 gateway. So from the dropdown, we only have one cluster, one edge cluster, and that has our 2 edge nodes in it. So I'll select that, and then I'll scroll down and click on save, and then we'll click on no. And there is our Tier 0 gateway. So if we go back to our network topology, there it is right there. So next, let's go ahead and configure two Tier 1 gateways. They're going to be called Tier 1 Gateway A and Tier 1 Gateway B, and we'll connect them also to the respective segments and also associate them with the Tier 0 gateway that we just created. So on the left, with networking still selected, we'll click on Tier 1 gateways. We'll click on Add Tier 1 gateway, and we'll create our first Tier 1 gateway. Based on our plan, that'll be called Tier 1 Gateway A. We'll go ahead and use active standby for that one as well. And then we're going to link this to our Tier 0 gateway with the dropdown, and there's our Tier 0 Gateway 0 we created just a moment ago. So we'll select that. So we need to specify the edge cluster, the cluster of edge nodes that we're going to use. And from the dropdown, we only have one. That's our nested edge cluster. We'll select that. And then there's one other element I want to change other than the defaults, and that is route advertisement. Under route advertisement for this Tier 1 gateway, we want to go ahead and enable advertisement of all connected segments and service ports. That way, if we add additional segments like segment 10 and segment 20 with their respective IP addressing, those subnets can be automatically advertised up to the Tier 0 gateway. And that's what this little slider is going to do for us right here. So we want to make sure we enable that. Otherwise, the Tier 0 gateway won't, by default, have the route for those directly connected Tier 1 networks. So with that set, we'll scroll down and click on Save. And actually, I also want to configure a little bit more, including DHCP services. So we'll click on Yes here. So for DHCP config, we'll click right here on Set. And we want to go ahead and provide DHCP services. So I'm going to select our profile that we made in the previous video, click on Apply. And now, any directly connected segments where we want to implement DHCP services, we can leverage the gateway DHCP services enabled right here on this Tier 1 gateway. So with all that in place, we'll click on Save. And then we'll click on Close Editing. And now we have our Tier 1 Gateway A. Let's just click on the Network Topology tab for a moment and verify it. There we go. So here's our Tier 1 Gateway A. Let's go ahead and create our second gateway, which will be Tier 1 Gateway B. So back to the Tier 1 gateways we go. We'll click on Add Tier 1 Gateway. And based on our plan, we'll call this Tier 1 Gateway B. It'll also be active standby. We'll use the same edge node cluster. And we'll also link it to our same Tier 0 gateway. And we'll make sure we're advertising routes here as well. So regarding route advertisement, we'll select this option here for advertising all connected segments and service ports. And we'll scroll down, click on Save. And then I want to continue configuring. I want to configure the DHCP services here. So we'll specify DHCP server. We'll specify the server profile, and we'll click on Apply. And then we'll scroll down, click on Save, and scroll down, click on Close Editing, and good to go. So now if we click on Network Topology, now we have our Tier 0 gateway. Let me zoom in a little bit here. So here we have our Tier 0 gateway. It is connected to Tier 1 Gateway A here and Tier 1 Gateway B here. It automatically uses IP addressing scheme for connectivity between it and the two Tier 1 gateways. And if we hover over services here for the Tier 1 gateways, we have the default gateway firewall rules. And because we enabled DHCP services, we also have the ability to provide DHCP services for directly connected segments. So that reminds me of our last step, and that is to take these two segments here and to associate them with their respective gateway. So we want Tier 1 Gateway A to be connected to segment 10 and Tier 1 Gateway B to be connected to segment 20. And we do that from the perspective of the segments themselves. So we'll go to the segments section here under connectivity, and we'll first edit segment 10 by clicking on Edit. And then we'll simply say, hey, you are connected logically to Gateway A. So Gateway A will take the responsibility here of this IP address 10.10.0.1, which, if we hand out that via DHCP, will be the default gateway clients will use to get off of that local network segment. And also, while we're here, we'll click on Set DHCP Config and specify we want to use Gateway DHCP Server, and then specify our range. So 10.10.0.151 through 10.10.0.200 would be fine. And then for DNS, we'll use 8888. And that's in anticipation that we'll get them connected out to the internet eventually. And then scroll down and click on Save for the segment, and then click on Close Editing. And then once again, right here, we have the hyperlink in blue for the segment 10, indicating for the subnets here that there's DHCP services enabled. We'll do a similar treatment here for segment 20. So we'll click on the three dots, click on Edit, associate this with our Gateway B right there, and then we'll set up our DHCP config to use the Gateway DHCP services, and then we'll put in a range of 10.20.0.151 through 10.20.0.200, and then we'll put in a DNS server of 8.8.8.8, which at the moment, the clients won't have access to the outside internet to get to that DNS server, but after the next video, they will. And then scroll down, click on Save, and click on Close Editing. So let's take a look at our network topology by clicking on the network topology tab. So here's our tier 0 gateway. It has direct connections over to our tier 1 gateway A and tier 1 gateway B. And then below tier 1 gateway A, we have segment 10. And connected to gateway B, we have segment 20. And then if we expand the VMs there by clicking on them, we have A1 connected to segment 10. And on segment 20, we have B2. So let me go ahead and refresh A1 and B2 just to verify that they can get IP addresses from the DHCP services and also that they can ping each other. In fact, you know what we could do? So here are those two little VMs. I still have remote consoles open for them. And I'm going to go ahead and simply reboot them, which should cause them to get a new IP address. And actually, while that's happening in the background, we can verify that right here by going to Plan and Troubleshoot. And then on the left, going down to Traffic Analysis. And then clicking here on New to do a new trace flow. So I'm going to go ahead and collapse the left-hand side so we have a little more room right here. And now that those two VMs have booted up, we'll go ahead here to Virtual Machine and let's select A1. And it shows the IP address of 10.10.0.151. And sometimes it takes, I don't know, a minute or two between a VM coming up and getting an IP address before it's reflected here in the NSX Manager, because the NSX Manager is pulling this information from vCenter. So just be aware that if you just powered up a VM, you may want to give it a minute or two to be correctly reflected here. So let's go ahead and take a look at B2. It shows the address of 10.20.0.151. And we'll click right here on Trace to do a quick test just to verify basic IP connectivity between the two. All right, so that looks successful. So that traffic from A1 went through segment 10, then it went through gateway A, then it was routed through tier 0 gateway 0, then down to tier 1 gateway B, down through segment 20 as it finally got delivered, and the reply traffic would go the reverse path. So the cool thing is about TraceFlow is that it can show us the play-by-play with all the details involved, including, this time, at least one edge node being used because we set up the high availability for the routing. So .31 is ESXiA, so it logically processed the distributed firewall, logically the traffic going through segment 10, logically traffic going through gateway A, and then after that routing decision, it forwarded the traffic from the tunnel endpoint on ESXiA over to the tunnel endpoint on edge 1. Now I know that's edge 1 because right here in the output it's showing that edge 1 is the next node that's actually doing the processing. So edge 1 got the packet, de-encapsulated it, and then edge 1 logically did routing decisions again based on gateway A. It logically did the processing for the firewall rule, also on gateway A. And then it did the logical processing for that traffic going through our tier 0 gateway right here. And then it did the logical processing for that traffic being routed through gateway B. Fantastic. Again, this is all edge 1 doing all this work, this logic. So here's gateway B and the edge firewall associated with gateway B. And then logically being processed through segment 20. And then being forwarded from its tunnel interface here on edge 1 over to 192.168.1.32, and that is the IP address of ESXiB. And then ESXiB continues to process it, logically going through the distributed firewall, which it passed, and then it was delivered to the VM B-2, which is running on ESXiB. So as we look at the traffic that logically went like this through the network, and for that logical flow of traffic that would have come from the VM into ESXiA, who would process the distributed firewall rules and routing decisions, ESXiA using its tunnel endpoint, then forwarded up to Edge 1, who also did gateway firewall rule processing and route processing for the routers involved in the path. And then after all the routing decisions were done, it then forwarded it from its tunnel endpoint down to the tunnel endpoint on ESXiB. Again, this is Geneve tunneling as it's being sent over the tunnels. And then ESXiB de-encapsulated it and then forwarded it to the final destination, which was B2. And there's also a possibility I'd like to point out right now that we could have also had Edge 1 forward that traffic over to Edge 2, who would then forward it down to ESXiB. An example of that would be Edge 1, if it's the active node between Edge 1 and Edge 2 for Gateway A, and then Edge 2 is the active node supporting Gateway B, and that traffic needs to flow through all three of the gateways. That would be an example where the traffic flow, instead of going from ESXiA to Edge 1 down to ESXiB, the traffic, once Edge 1 processes this part of it, would then forward over to Edge 2 for this part of it. And another variable would be who is the active node for the Tier 0 gateway as well. However, in either case, if we have Edge 1 and Edge 2, and Edge 1 is active for one or two of these logical gateways, and Edge 2 is responsible for yet a different logical gateway, and it's active for that one, then the traffic would go from the VM to the host, from the host to edge 1, and then as that routing process continues, forward it over to edge 2, and then for the final delivery, who could send it down from its tunnel endpoint over to the ESXiB's tunnel endpoint, who would then deliver it to the final client. And you know what? Because we have our nested lab environment, we can actually manipulate that and demonstrate that in action. So currently, based on the traffic flow we just saw, I'm thinking that edge 1 is the active node for all 3 of these logical gateways because it didn't bother sending it over to edge 2. So let's confirm that first, and then we'll modify it. So here in the NSX Manager, let's click on the Networking tab. I'll expand the left-hand column, and let's go down to Network Topology, and let's take a close peek here at the Tier 1 gateway on the left. Let me zoom in a little bit. This is Tier 1 Gateway A. If we double-click on the gateway, it's going to show us the details about who's active. So this is showing us that for Gateway A, Edge 1 is the active node. And Edge 2 is the standby, meaning it doesn't have to do a lot of work. It's simply hanging out in case Edge 1, something happens to it, it can go active. But at the moment, Edge 1 is active for Gateway A. So that's Gateway A. Let's go take a look at Gateway B. We'll double click on Tier 1 Gateway B and zoom in. And sure enough, Edge 1 is active on that one as well. So to demonstrate how the traffic could flow, for example, from one edge node that's responsible for Gateway A to a different edge node that's responsible for the processing for Gateway B, let's change the active node for Gateway B and change it from Edge 1 over to Edge 2. So to do that, we'll go to our Tier 1 gateways here on the left, and we want to go ahead and change who the active edge is for Tier 1 Gateway B. So we'll go ahead and click on the 3 dots for Tier 1 Gateway B and click on Edit. And then here for Edge Cluster, we have specified our nested edge cluster, and by default, it's automatically allocating the edges. So I'm going to disable that. So here, I'm going to specify Edge 2 should be the allocated edge node for Gateway B, and that way that'll force it to be active. So I'll scroll down, we'll save that, and click on Close Editing, and let me collapse that. And let's go take a look at the topologies just to verify that for Tier 1 Gateway B, that the active edge node now should be Edge 2. So we'll go back to Network Topology, we'll zoom in to Gateway B, we'll double click on it, and for Edge 2, it's showing, it's only showing one node, it's showing a standby, so that may take just a moment to update. Let me click on refresh here. So after a moment or two, I just clicked on refresh again, and now it's currently reflecting that Edge 2 is the active node supporting Tier 1 Gateway B. So now, if we were to do a trace flow, and let me click on back so we can see the full topology, here's what we'd expect to see. The traffic would go in from the VM to ESXi. It would process some distributed firewall rules and process some routing. And upon that, it would discover it needs to forward that to the active node, the edge node that's responsible for Gateway A, in which case it would forward it up to Edge 1, who would do some processing and lookups regarding the routing process. And then because that traffic would eventually need to go through Tier 1 Gateway B to reach the final target, and Edge 2, if it's the active node there, that would cause Edge 1 to tunnel that over to Edge 2, who would then proceed to process the firewall rules as well as routing, which would cause Edge 2 to forward that traffic over the tunnel down to ESXiB, who would then de-encapsulate it and forward the final traffic down to the VM. And a quick way to verify that that is the case is to go back to Traceflow with Plan and Troubleshoot. On the left to Traffic Analysis, we'll click on New and click on Proceed, and then we'll put in the VM. So we want VM A1 on the left, and on the right we want the VM called B-2, and we'll click on Trace. So what we expect to see here as a result is traffic from the VM to ESXi to eventually Edge 1, who tunnels it over to Edge 2, who tunnels it down to ESXiB, who then forwards it down to the final client. And we can verify that through the graphic right here. So we can click on the little nodes involved, and that will show us the nodes. There's ESXi at .31 and ESXi at .31. And then here for the Gateway A, if we click here, it's showing us it's Edge 1. And then if we go over here on the right-hand side to Gateway B and click on the little icon here for the node, that's showing it's Edge 2. And then for the final delivery down to the client, if we click here, that's ESXiB at .32. We can also verify that by looking at the output right here. So ESXi originally, who sends it over to Edge 1, and then after Edge 1 is done, it sends it over to Edge 2, and then Edge 2 does the logical processing for Gateway B and also for the Edge firewall rules, before then delivering it down over the tunnel down to ESXiB at this IP address, who then delivers it to the VM hosted on ESXiB. And now because those edge nodes are being used, they also are going to have more information that the NSX manager has placed on them. For example, if we go back to the command line interface here on Edge 1, which is the active node for Gateway A, and we do a get gateways and press enter. Here on Edge 1, the VRF0 is the routing table for the tunnel interface and the default gateway it's using on the transport network. And then the other virtual routing and forwarding instances, like think of them like separate routing tables, are for the 3 distributed routers. So here we have the Gateway 0 distributed router, and we have the Gateway A distributed router, and the Gateway B distributed router. And we also have a services router, which Edge 1 is active for, which is including the DHCP services component. And to go into the individual routing table for any of these VRFs, there's a few ways of doing it. The easiest option is to type in VRF space and then the number, and that'll take you into that services router. So if we type in VRF space 2, to go into the services router for the Tier 1 Gateway A, and then do a get forwarding, and press enter, this is showing us the routing table for Gateway A, which includes reachability to the DHCP services. It includes connectivity between the Gateway A and the Tier 0 gateway, and it's also including the directly connected network that's associated with segment 10. And there's also some subnetting for internal routing logically between a logical services router and a logical distributed router that are both present on this edge node. Then down below that, there's also some routing for IPv6. Which, although we didn't configure, we also didn't disable, so that's why it's showing up here as well. So now that we have connectivity inside our NSX virtualized environment, and we're now using 2 Tier 1 gateways and 1 Tier 0 gateway, what if we wanted these VMs, these guys right here, to have access to devices outside of the NSX networked environment? For example, maybe we have a router right here, a physical router or an external router that has connectivity to the internet. How do we glue those networks together or provide routing capabilities between our NSX environment and the outside world? Well, that, my friend, is exactly what you and I get to address in our nested lab environment in the very next video. So I'll see you there for that very, very soon.